A prism is a solid object with two identical ends and flat sides. The shape of the ends give the prism a name. This is a triangular prism because the ends are triangles. And here we have a pentagonal prism because the top and the bottom and the top are regular pentagons. What do I mean by a regular pentagon? I mean that each of the 5 sides of the pentagon is the same length. Here is a third prism, and we know this by the more familiar name of a cuboid. So we have a rectangle on the bottom and another rectangle on the top. We could call that a rectangular prism. Here is one more prism. We can call this a square prism because the bottom and the top are squares, but because the top, bottom and height are all the same length, we know this by the more familiar name of a cube. And here is one last prism. The base of the prism is a circle and the top is a circle. We know this as a cylindrical prism, or by the more familiar name of a cylinder. Now there's one last thing that I'd like to say about a prism. We've got 5 examples. Imagine cutting through the prism at a certain point. Let's just take the last one, the cylinder. If I was to cut through the prism here, or here, or here, or anywhere along its length, I would get the same circular cross section as I have here and here. And that applies to all regular prisms, which is to say when the top and the bottom are of the same type. The volume of a prism is given by the formula V equals area of the base times the height, and we can abbreviate that to V equals AH, where A is this area here, the area of the base, and the height is this dimension here. So here's a first example of a shape that we're familiar with. This is a cuboid, a square-based cuboid, or a square prism. Now notice I use the word or the description square prism, but it's not a cube because the height is different from the lengths of the sides of the base. Anyway, the formula for the volume of the shape is V equals AH, where A is the area of the base. Now this is the base here. We can work that out separately, so it's going to be length times breadth, 10 times 10 equals 100 centimetres squared. So 100, and then we multiply by the height, which is 18 centimetres. 100 times 18 then gives us 1800 centimetres cubed. Now here we have an example of something we haven't seen before. This is, well, this shape, the two-dimensional shape which makes up the top, has 1, 2, 3, 4, 5, 6, 7, 8. So this is an example of octagonal prism. If we want to work out the volume of the shape, we need to be given some dimensions. Well, let me just say then that the area of this face is 125 centimetres squared, and that the height of the prism is 8 centimetres. So volume equals area times height, 125 times 8, and that gives us 1000 centimetres cubed. Here we have an example of a triangular prism. If we look at the base, we can see that there are 3 different dimensions. We've got 4 and a 7 and a 6. Now let's just focus on the triangle. If we're to work out the area of the triangle, then we use the formula. Area equals 1/2 of the base times the height. Now the base and the height of a triangle must be at 90 degrees to one another. So if we look at these 3 dimensions, which 2 of those are at 90 degrees? Well, I hope you can see it's the 4 and the 6. So the 7 is not relevant. And I'm going to put a line through that. We're not going to use the 7. That's the length of the sloping edge of the triangle. So the area of the triangle then is 1/2 of 4 times 6. 2 times 6 is 12 centimetres squared. And the volume of the prism, A times H. Now, here's another thing. You'll notice that the letter H for height appears twice. This H here is the height of the triangular base. This H here is the height of the prism. So, area times height, 12 times 12. It just so happens that the area of the base and the height of the prism are the same. That gives us 144 centimetres cubed. Example 4, the final example. Here we have a triangular prism. We're given the volume and some of the dimensions, but we're missing one of the dimensions. Now, remember what I said in the last example, we have to be careful with triangles. This 5 is the length of the sloping edge. If we're going to work out the base and the height of the triangle, or the area of the triangle, then the base and the height must be at 90 degrees. So this here is the height, and this here is the base, and this, it would appear, is the dimension that we're trying to find. So the 5 is not relevant to our calculation. So how do we proceed? Well, the volume of a prism is given by the formula A times H, which is to say the area of the base times the height. 198 equals A times 11, because we don't know what the area of the base is. Now, how do we proceed from this point? We're going to divide by 11. So A then equals 198 divided by 11, and that gives us 18. Now that must be not 18 centimetres, but 18 centimetres squared, because this is an area. The area of the triangular base is given by the formula A equals 1/2 of the base times the height. We know that the area is 18. We don't know what the base is, but we do know that the height is 3 centimetres. Now, this is a bit problematic. What I'm going to do is to multiply by 2 to get rid of that dividing 2. So 2 times 18 is 36 equals 3b. And the last thing I'm going to do is to divide by 3 to get b on its own. b equals 36 over 3, and that gives us 12 centimetres. So the base length of the triangle is 12 centimetres.